Our last unit, we looked at two-column proofs, and we were looking at that with our algebraic equation. So solving a normal algebraic variable and looking at how we can give our reasoning. We're going to look now at doing proofs with parallel lines and using those types of angles we learned and the converses we learned to prove a certain statement. Just like before, we're going to be given a statement or maybe a couple of statements, and we're going to be given a statement that we want to prove. So remember, these given statements should always go first, and then if you've done the proof right, your proof statement should be the very last thing. For this proof, we're looking at our picture on the right. So we see that we have lines J and K that are parallel, and there's a transversal with them. So we're going to look at some relationships. Our first statement is our given statement. So they told us that angle 4 and angle 7 are supplementary angles. And again, that reason is given. If I look at angle 7, I can also see that angle 7 is supplementary with angle 6. If I write that statement, my reason is going to be that they are a linear pair. So if I have supplementary angles, they are a linear pair. Don't forget we have that vocabulary word. Now that I have that angle 4 and angle 7 are supplementary, and angle 6 and angle 7 are supplementary, I can say that angle 4 is congruent to angle 6. My angle 7 didn't change at all, so I can say that 4 and 6 are congruent because they both add to 7 to make a supplementary angle. When we write that reason, we can say a congruent supplementary theorem, or we could say the transitive property. And then now that we have angle 4 and angle 6 are congruent, we can look at what kind of angles those are. 4 and 6 are our alternate interior angles. So using our converse of alternate interior angles, we can say that lines J and K are parallel because we have the alternate interior angles converse. So remember, if we can prove that the angles have that same relationship that they normally would with parallel lines, we can say that the lines are parallel. Looking at our second example, they gave us the picture on the right, and they gave us two given statements. So they told us that line A is parallel to line B, and then they told us that angle 2 is congruent to angle 3. When we see the equal sign with the squiggle on top, that means congruent. So I'm going to write those given statements first. So A is parallel to B, and that's given. And then I have to write my second given on a second line. So angle 2 is congruent to angle 3, and both of those were given to me. If I look at my picture, I see that I somehow need to bring angle 1 into the equation. Well, angle 1 and angle 2 are alternate interior angles. I have my parallel lines and I have this transversal. So I can also say that angle 1 is congruent to angle 2 due to the alternate interior angles. Once I have angle 1 is congruent to angle 2, I can use that transitive property. I can take out my middleman of 2, and I can say that angle 1 is congruent to angle 3. And again, that is our transitive property. Looking at a couple other examples, for number 3, we have our picture on the right, and our first given statement is that angle 1 is congruent to angle 7. So we're going to write that that is our given. It can also be helpful to mark the picture. Since I'm doing this on the computer, I don't have that option to, but I can show you in class how to mark those pictures. Our next statement that we want to look at is somehow dealing with our lines, because we need to somehow prove that angle 4 and angle 8 are congruent. Angle 1 and angle 7, if they are congruent, that means that they are our alternate exterior angles. If I'm using that alternate exterior angles converse, I can say that line L is parallel to line M. Once I have that those lines are parallel, I can come up with any other angle relationship that we've looked at. So if I want to say that angle 4 is congruent to angle 8, now that I have those parallel lines, I can say that using the fact that they are corresponding angles. So we just had to prove that the lines were parallel before we could say that 4 and 8 were definitely congruent. For number 4, our given statement is that angle 5 and angle 8 are supplementary. So if I write that in as my statement and my reason is given, if 5 and 8 are supplementary, that means that they are my same side exterior angles, or I'm using that same side or consecutive exterior angles converse. If I'm using the converse, then my statement is going to be that R is parallel to S. My line R is parallel to line S. Once I have that, I can say that any other angle relationship is there. For angle 3 and 6, I can say that they are congruent using the fact that they are alternate interior angles. For example number 5, we were given two statements, and we want to prove that line A is parallel to line B. So if we're trying to do that, we need to make sure that we're setting up our angles correctly. Our first given statement is going to be that line C is parallel to line D, with our reason as given. And our second statement is going to be that angle 1 is congruent to angle 7, again with that given reason. So if we know that angle 1 and angle 7 are congruent, right now 1 and 7 don't have the same transversal. I can't jump and say that A and B are parallel since they told us that 1 and 7 are congruent. What would help me to prove that A and B are parallel is using this angle 3. 1 and 3 have a relationship and 3 and 7 have a relationship. So I need to somehow get angle 3 involved. If we look, angle 1 and angle 3 are corresponding angles, and if they're corresponding angles, I can say that angle 3 is congruent to angle 1. If I look at statement 2 and statement 3, I can take out my middleman of angle 1 and say that angle 3 is congruent to angle 7 using my transitive property. Once I use that transitive property, I can see that angle 3 and angle 7 are also corresponding angles. So I can say that A is parallel to B using the corresponding angles converse. Number 6, our given statement is that J is parallel to K, which means we can now use our different types of angles to piece stuff together. And we're trying to prove that angle 1 and angle 7 are supplementary. If I look here, I need to get angle 1 and angle 7 in my statement somewhere so I can prove that angle 1 and angle 7 are supplementary. If we start with getting angle 7 involved, we can see that angle 5 and angle 7 are corresponding angles since we have that J is parallel to K. So I'm going to say that 5 is congruent to 7 with my corresponding angles. If they are congruent, that means that angle 5 is equal to angle 7. The measure of angle 5 is equal to angle 7, whatever that is. And that's our definition of congruence. The reason that we want to say that is I can see that angle 1 and angle 5 are also supplementary angles. They're forming that straight line. And that's the definition of my linear pair. If they're supplementary angles, then that means the measure of angle 1 plus the measure of angle 5 equals 180 degrees. And that's the definition of supplementary angles. Now that I know that the measure of angle 1 and the measure of angle 5 equals 180, I can substitute in for angle 5 because for step 3, we said that the measure of angle 5 and the measure of angle 7 are equal to each other. So I can now say that the measure of angle 1 plus the measure of angle 7 is equal to 180 degrees. And with that step, all I did was substitute. I replaced my measure of angle 5 with my measure of angle 7. If the measure of angle 1 and the measure of angle 7 equals 180 degrees, then that means that the angle 1 and angle 7 are supplementary, and that's using the definition of supplementary angles. So I know it seems like a lot to write it all out. Of course, if angle 5 is congruent to angle 7, then the measure of angle 5 is going to be equal to the measure of angle 7, and it seems redundant to write that, but step 3 is what allows us to make this replacement between step 5 and step 6. For our last example, we're going to look at number 7. So we were given that AB is parallel to CD, so that's going to be our first statement, and our reason is that it was given. And then they also told us that the measure of angle ABC is equal to the measure of ADC. So ADC is this angle down here, it's where D is, and ABC is this angle up here where B is. Remember that middle letter is the angle that I'm talking about. In order to prove that AD is parallel to BC, we need to get our angle relationships to where they're dealing with one transversal. So right now they told us that ADC and ABC are equal, and they don't have the same transversal. So we need to somehow move one of our angles. When we do that, we can say that the angle of DAB and the angle of ADC are supplementary angles. They're supplementary because I have consecutive interior angles or same side interior angles. And that is our reason. Once I know that, I can actually write out what it means for them to be supplementary. So if they're supplementary, that means that the measure of the angle DAB plus the measure of angle ADC equals 180 degrees by our definition of supplementary angles. Just like our last proof, if I have a statement that says that angle ADC is equal to angle ABC, I can use my substitution property and say that the measure of angle DAB plus the measure of angle ABC equals 180 degrees by substitution. If I have that these two angles equal 180 degrees, then that means that these two angles are supplementary. And again, that's the definition of my supplementary angles. If we look, I now have angle DAB and angle ABC. So they're sharing the same transversal. They're sharing the line AB as their transversal, which means that AD and BC we can say are now parallel using our definition of consecutive interior angles converse. So again, if we're looking at DAB and ABC, and AB is our transversal, those two angles are consecutive interior angles. And we're using the converse if we're proving that lines are parallel to each other. So it's a little bit more work, a little bit more complicated than the proofs that we've seen before, but we're still just doing it step by step, and we're making sure that we can piece things together correctly. And that's for parallel lines proofs.